Today, we're going to implement a basic clustering algorithm using the k-means algorithm to cluster the iris dataset. Let's get started. First, let's import the necessary libraries. We'll need NumPy for numerical operations, Pandas for data manipulation, scikit-learn for the machine learning model, and matplotlib for visualizing the results of our clustering. Load iris function will fetch the famous iris flower dataset for us. It's like having a pre-built collection of flower data ready to analyze. We are also importing k-means class from the scikit-learn library, which is the heart of our clustering algorithm. K-means will help us group similar data points together, like sorting colorful candies into distinct bowls. Next, let's load the iris dataset, which is a classic dataset for clustering problems. Here, load iris function retrieves the iris dataset and stores it within the variable iris. We are extracting the actual data from the iris object and storing it in the variable x. This data represents the measurements of various flower features, like sepal length and petal width. Then we create a data frame, which is like a table from the iris.data and assigns the feature names from iris.featurenames as column labels. Finally, we display the first few rows of our data frame. This gives us a sneak peek at the actual flower measurements we'll be working with. The output shows the first few rows, indicated by head, of a table created from the iris dataset. Each column represents a feature of the flower, such as sepal length and petal width. The rows display the actual measurements for individual flowers, allowing us to see the range of values for each feature. Now that we have a glimpse of the data, it's time to build our k-means model. Imagine this model as a sorting machine that will group similar flowers together based on their features. This line creates a k-means model instance. Here's what the key parts mean. K-means specifies the type of model we're creating, which is k-means clustering. N-clusters equals 3. Argument tells the model that we want to group the data into 3 clusters. You can experiment with different numbers of clusters to see how the results change. Random state equals 42. Sets a random seed for the model. Think of it like a starting point for the clustering process. Using a seed ensures that whenever we run the code, we get the same results for easier comparison. It's time to train the model. Imagine feeding the flower data to the k-means machine, and it'll use its clustering magic to group the similar flowers together. Here we train the k-means model on our data. Think of it as the model analyzing the flower data and figuring out where to place each flower in the 3 clusters we defined earlier. With the model trained, we can get the cluster labels for the data. We want to know which cluster each flower belongs to. Here we extract the cluster labels assigned to each data point by the k-means model. These labels will tell us which cluster each flower belongs to. The output displays the cluster labels assigned to each data point in the iris dataset by the k-means clustering algorithm. The numbers 0, 1, and 2 represent the 3 clusters that were formed, indicating the group each flower belongs to based on its similarity to other flowers in the same cluster. Let's visualize the results to see how the clustering worked. We are using a scatter plot to plot the flowers based on their sepal length and sepal width. We also color the points according to their cluster labels. The output shows a visual representation of the k-means clustering applied to the iris dataset. It's a scatter plot where each dot represents a flower. The position of the dot shows the flower's sepal length, horizontal axis, and sepal width, vertical axis. The colors of the dots correspond to the clusters assigned by the k-means algorithm, 0, 1, or 2. This allows you to see how the flowers are grouped based on their sepal measurements, with similar flowers having similar colors and positions in the plot. That's it. We've successfully implemented k-means clustering algorithm to cluster the iris dataset. By visualizing the clusters, we can see how the algorithm grouped similar flowers together based on their sepal length and sepal width. Thank you for watching, and don't forget to like, share, and subscribe for more coding tutorials.